So when it comes to JavaScript frameworks, usually there's a couple of kind of priorities or potential performance problems that you might face. And these are usually something to do with getting that first content down to the user, then getting that content interactive, and then when the user's actually using the tool, making sure everything stays fast and responsive. Now, when I see the same problems again and again, I just think automation. And it's my belief that our tools should be doing a lot more of the work and we should be doing less of it, especially when it's the same problem again and again. And so the idea of the pit of performance is that if you dig a hole deep enough that performs well, you can't get out of it. So this is Svelte, which we've heard a little bit about. It's the same as any other JavaScript framework, except it runs at build time when in CI or in your local dev environment, instead of at runtime when the user loads your app. So what I'm going to do is I'm going to go through kind of Svelte's solution to these problems of first render, first interactive, and keeping things fast afterwards. So the first thing is to serve static content. So the way you would normally do this in most frameworks is some process of server rendering, and that's not much different in Svelte, except again, instead of it being passing a virtual DOM to some kind of string renderer, there's a specific compiler output. So you just tell the Svelte compiler, I want the SSR version instead of the DOM version. And instead of giving you a bunch of code that updates the DOM, it'll just give you some functions that basically just concat strings. So it's much, much faster than messing around with component trees at runtime. So one other way you can do it is by requiring this Svelte register, which will register an extension with Node. This won't work if you're kind of importing JavaScript modules inside your components. Then you'll need to resolve those dependencies with a bundler. But in a simple case, this can work. So app.render, you pass in the props, and you get back an object with a head, HTML, and CSS properties. And you can just use those in your app. You can use this to build static files, and you can actually serve that HTML to your users, or you can do more traditional SSR by sending this down in response to some kind of API request. So not the most interesting thing, but serving static content is pretty important, and an important base if you're going to follow progressive enhancement principles as well. So the next thing we have to do is we have to get this interactive. So now we've got to navigate this really expensive network, parse, compile, and execute step of the browser. And this is a process that you have very little control over. If the network's slow, the network's slow. There's things you can do to speed things up your end. But if it's a slow network, then there's not much you can do. And fast networks can be slow, and fast devices can be slow. The only real solution that you have is to send less down the wire. It will be faster to load, it will be faster to parse. But importantly, because we're dealing with DOM operations, the execute phase of our JavaScript is going to be far more expensive than if you're doing very, very little DOM work. So the cost is even higher. So the problem with most JavaScript runtimes is they're pretty much all or nothing. It doesn't really matter if you only need some of it, you get all of it. And we're shipping unnecessary code. So the aim is, well, the hope is that we can ship just what is needed for our application. But a runtime framework doesn't know what you need until you run it. It's just there. It gets called. We want to do this. So Svelte does this, and it's kind of like, I see it like backwards tree shaking. Rather than shaking out the code you don't need, it just explicitly includes the code that you do. So this is a very, very simple Svelte component. It's a H1 with an event listener, a click, a style attribute, and a transition, because Svelte has first-class support for transitions when DOM is entering and leaving the document. And we've got a component. So what Svelte's going to do is it's going to parse this component into an abstract syntax tree. it's going to analyze that syntax tree, and it's just going to work out what's going on, what's being used, and what do we actually need. So you can see there's an element, so it imports the element runtime and generates the necessary code to add that to the DOM. There's a click, a style attribute, so we get the attribute runtime, the transition, and finally the component. And it is this granular. It generates this kind of code, which I'll attempt to show. So this is hopefully working. It's loading the compiler. Let's see if I write something. Okay, well, we'll have to skip over that, unfortunately. So this is the real-world benefits of this kind of thing. Is that this is an autocomplete, so it's just a simple autocomplete. It doesn't do much. But this is 4 kilobytes minified, and it's 2 obviously it's really small and you probably can't see it, and it's 2 kilobytes if it's minified in gzip. So to take a more complex example, so this is an ease visualizer that I wrote for the Svelte docs a little while ago, and this has a lot more of the runtime. This has kind of bindings to properties, events, child components, states updated, etc. And this is 20 kilobytes minified, but it's still only 7 kilobytes minified in gzip. That's smaller than some runtimes. So we've got small bundles, we've got our static content. So hopefully at this point our user is still with us. They haven't left yet, and now we need to make sure they stay. And we do that by doing less work. This is how we keep things nice and smooth. Svelte doesn't compare structures at runtime to work out what should change. This next part's probably not going to work either. So I'll explain instead. So a Svelte component doesn't re-render. It just runs top to bottom once. Every time you instantiate a component or create an instance of one, it just runs top to bottom. So this means that we need to somehow notify the compiler that state has changed. And there are 2 ways of telling Svelte to react to updates. And the first is with the assignment operator, which, if I zoom in, you can see here we are assigning a new date to time in a set interval. And so this will update the time at the top, which is component state. So what you're not seeing is a clock that doesn't update, and that's because it depends on these hours, minutes, and seconds values. And obviously, as this is executed once, it runs through, and we would have to give Svelte some information. We need to tell it that these values should update, the hours, minutes, and seconds values, whenever time updates. And we do this by adding this marks hours as reactive, and it says when your dependencies change, you should also change. And because that value is used later on in the DOM, that would update the DOM. So essentially, what Svelte's doing when it sees these top-level variables, which are classed as component state, is it's looking through the component for references to them. So here you can see that name, the variable, is also used as the text data for this text node after hello. And whenever this event handler is called, then the name value needs to be invalidated. We need to let the runtime know that that value has changed. And when and only when that changes, we'll update the text data. And we do this directly. Okay, so I want to show my app, assuming this app works now. Okay. So I've got a simple app. Calling it an app is pretty generous, but I made it for you. And what happens is we click this button to do some expensive stuff, and we can hover, and we can. This is a. I should reload this. Okay. I should go back to my terminal and find the actual link. Okay. It takes a minute to load in because what's going to happen in the background is it's going to parse a 150,000 line markdown file to simulate some work. It's clearly not working. Let me restart it.
Can someone pray to the demo gods?
Everybody prays to the demo gods.
I volunteer as tribute.
Okay. So let's hope this works. So we hover, everything works. We'll have a counter counting down to 0. And so let's do, right, good. So it doesn't work, it's broken. Everything stays blocked until the parsing has ended, because it's obviously blocking the main thread. If you ever consider in parsing 150,000 lines of markdown in the browser, you might want to reconsider. But now, what I want to do is I want to put this on a background thread. I want to put this on a worker. I don't want this automatically to be kind of delegated, hopefully run in the background, and it will just let me know when it finishes. Now, this isn't Svelte syntax, this isn't supported, but what I want to do is this, and I want it to automatically just spawn a worker and do this for me, so I don't have to, because I don't like the worker APIs. Let's see if that's rebundled. It has. Let's reload. Okay, let's see. And it does work. It works perfectly. And I knew that was going to happen. Now let's see if the sliders will come back. So what I did here is I used a preprocessor. Now I'm not necessarily recommending everybody does this, but I'll just forget it. So preprocessors allow you to transform some content before it hits the compiler. So Svelte will always expect valid Svelte syntax, but essentially a preprocessor allows you to write anything you want in your components, as long as you transform it before it hits the compiler, and this is absolutely fine. Now this is routinely used. So there are 3 types of preprocessor. There is a markup preprocessor, a script, and a style. So the markup receives the whole template in its entirety, exactly as you wrote it. The script receives just the contents of the script tag, and the style receives just the contents of the style. And this is generally used for compile to CSS languages. So you could take your SCSS in this case, and you could compile that to plain CSS, if that's what you prefer. It could be used to simplify authoring. So I wrote a markdown stroke Svelte syntax preprocessor called MD-Specs. It's basically MDX, but for Svelte, and it takes in some syntax. It compiles it down to just vanilla Svelte. Anything that hits the compiler has to be processed. So, but you don't just have to use it for that. You could use it for something else as well. So, in this instance, what I'm doing is I'm passing this to an AST with the tools that Svelte provides, and I'm looking for this worker labeled statement. And if I find a worker labeled statement, I know that I need to, it's okay to try and pull out the correct information, spawn a worker, and generate the correct listeners to make this work. And what this roughly gets compiled to is something like this. Now, I'm not suggesting you write your own compiler macros or start inventing your own syntax, but it's more just pointing out the benefits of having a template that is designed from the ground up to be statically analyzable. Gives you the opportunity to perform kind of categories of performance optimizations that are often out of your reach, especially with JavaScript being a dynamic language. You often can't work out what's actually going to be the contents of, say, a function call, especially when props are going to be passed in at runtime. You just can't have that. You just can't get that information. It's why Svelte uses templates in the first place. And so, although it benefits Svelte, it also benefits you. You can analyze and pass the AST however you want. And in this case, I've generated, essentially all I'm doing is spawning a new worker, which has been written to a file. So this is the worker file. It just imports the necessary function. That's a message event lister. And then when that, in this case, the parse function is completed, we'll post that on, which we will listen to over in our components. Like I say, not necessarily recommended this. Rich would, in particular, suggest you don't invent your own Svelte syntax, but okay, so that was eventful. If you are interested, then you should probably come and check out svelte.dev. We've got an interactive tutorial. We've got a REPL where you can try it out without installing anything. We've got a chat room where people will answer any questions you'll have. And this is me. Thank you.